Good morning, good afternoon, or good evening, depending on when you're joining us today. And welcome to speaking. But welcome to everyone who's joining us today for this discussion on transforming engineering education for a just, sustainable, and resilient future. My name is Savina Carluccio, and I'm the Executive Director of the International Coalition for Sustainable Infrastructure, or ICSI for short. And we are very happy to convene today's webinar together with the other co-hosting organizations, the UN Environment Programme and the Duke University Nicholas Institute for Energy, Environment and Sustainability. So today we are bringing together a brilliant panel to get different perspectives on a topic that we've been discussing for about 3 months now. Every 2 weeks, we've been meeting with a group of practitioners and academics and engineering educators and civil society representatives, so a very diverse group of people who are very interested in this topic of how do we make sure that future professionals, engineering professionals, are equipped with the skills, the knowledge, the expertise, well, not the expertise, more the mindset actually, to tackle the complex challenges that we're facing today and will be facing in the future. So this webinar is part of that series, and I welcome everyone who's joining us from the group that's been meeting regularly, but also welcome those of you that are joining us just for today's discussion as we opened it to the wider public. Because you're interested, obviously, in this topic. The aim today is to share some of the learnings from the series so far, but also to link it to a major event, international event, that is the conference climate change, COP30, that is happening starting today. In fact, we are starting alongside COP. So, and because we want to link this topic to what's happening around us, and we want to also bring the perspectives and the insights from the sessions we had so far and from today's session into the COP discussion that I will be joining in a couple of days. So just to maybe frame what we're going to be talking about. So this year's COP is being branded the Implementation COP. So we really want to pivot the discussion from theory to kind of discussing the challenges and sort of framing the problem into really implementing solutions at pace and at scale. This is actually coming from the UNEP, I think, recent publication that 75% of the infrastructure that will be needed by 2050 currently doesn't exist. So we got this massive opportunity for engineers who are the primary implementers and shapers of the built environment to actually implement a built environment and infrastructure that is, as the title of our discussion is, just, is sustainable, and is resilient. But we need to have the right skills and the right capability within the engineering workforce. So, and this is two-pronged, is the both upskilling the current professionals, but today's discussion is focusing on just what do we need to do to ensure the future professionals are ready for this. Something that I wanted to kind of touch upon before I just we hand it off to the moderator and have a panel discussion. It's just mentioning that this year's COP has got 6 axes, they call it. And so these are priorities and then the different topics that are being discussed at COP. And with an ambition, a really big ambition of this year's COP presidency to make sure that everyone comes together. For the very first time, the COP presidency has created what they call a global action agenda that includes all of these 6 themes. And if you look at them, in all of these topics and all of these different axes, there is a role and a space for engineers. And so there is really an urgent need to actually create the future professional and upskill the current ones, and which is why we want to be talking about this today. The something else I wanted to mention is that this year's COP is not shown on the screen, but it's a word that is used is mutirão. Mutirão is a Brazilian Portuguese word that means it's got origin from the native and indigenous people from the Amazonia, and it means a collective effort. So this is really the ambition. It is a collective effort. Everyone needs to come to the table. Everyone has got a role. And today we want to be focusing on what is the role of engineers here, and then how do we ensure that we transform engineering education to tackle this this challenge and pull our weight and contribute. So I'll before hand over to you to the moderator Liz Losas from Duke University. I just wanted to maybe say something a little bit more around the need to apply system thinking and the need to apply transdisciplinary approaches and think differently, and then to really accelerate that type of solutions and innovation that is needed here, and the need to deliver resilience and nature positive outcomes in all the solutions that we develop. So this is something that it's really important, and I hope it will come out in our discussion. So enough from me. I'm handing it over to our moderator, Liz Losas, and over to you, Liz, to take us through the panel discussion.
Thank you, Sabina, and thanks so much for inviting me to be here. I'm Elizabeth Losses. I'm at Duke University's Nicholas Institute for Energy, Environment, and Sustainability, and we have been working with ICSI and others to develop a whole network of ISLE or infrastructure sustainability for learners, learning hubs. And this is part of it. And I can't imagine a better place than trying to apply what we've been doing over the last few weeks under ICSI's leadership to what's happening in COP. Because really, I think this is where the rubber hits the road. The COP can come out with all sorts of great new policies and commitments and pledges, but if you don't figure out how to implement them on the ground, which requires the engineers of tomorrow being aligned with where these goals are, I think it's sort of a lost cause. So this is a great topic for COP, and we are delighted not only to have Sabina on the panel, but we are being joined by three really interesting experts that bring quite a few different perspectives. We have Professor Preeti Parikh. Sorry about that, Preeti.
That was perfect.
Who is the Professor of Engineering, Infrastructure, and International Development and Director at the University College London's Bartlett School of Sustainable Construction. And after Preeti, we'll be hearing from James Verree, who is the lead corporate sustainability at GHD, developing infrastructure for energy, water, and urbanization around the world. And then finally, Professor Bilal Ayu, who is the director at University of Maryland and College Park's Center for Technology and Systems Management. And of course, Sabina will also be joining the panel, and we've already heard from Sabina. So let's start by having each of the panelists give a few comments really following on where Sabina left her remarks, and that is that engineering education is only going to truly achieve the sustainability that we're talking about here at COP once systems thinking and transdisciplinary learning becomes really core, not a nice option but becomes a core part of the curriculum that the students get during their engineering education. So for each of the panelists, does this resonate with you? And what sorts of institutional and mind shifts must be critical to making this happen? And why don't we, Preeti, start with you?
Thank you so much, Elizabeth. And Sabina, thank you so much for having me, especially on day one of COP30. And Elizabeth, I absolutely agree with your statement around transformation. I mean, we are facing challenges, and then some of them are old challenges around climate change, but then they are meshed up with new challenges such as conflict. And the problem is that combination of those challenges then disrupt traditional models for planning and delivery of infrastructure. On top of that, if you think about institutions, whether they are global institutions or governments, their roles are changing, and AI is changing the way we do business on a daily basis. So now, if you think about the future jobs and skills in the engineering sector are going to look different. And this is a challenge that universities are grappling with on how can we refresh our curriculum to make sure that the jobs where the graduates have the skill sets for those new jobs. And this is where there is a need for kind of new way of thinking, a mind shift, transdisciplinary approach. And to give you an example, at University College London, we have an initiative called Grand Challenges, where we have seed funding to tackle climate change with the condition that academics from different faculties can apply for seed funding. And that brings together expertise from different disciplines, which in turn feeds into curriculum reform. But the pace of that is really not enough because we need to rapidly build up that knowledge around complex problem solving. And the challenge with engineering curriculum and the profession is that on one hand, engineering is a precise science. If you were to calculate, say, a bending moment of a beam, there is only one answer. But when it comes to our world, when it comes to our system, the future world is imperfect, it's dynamic, it's unpredictable. So we need to work with engineers and future engineers in our curriculum. So we are building technical leaders, but then leaders who engage with social scientists, who engage with anthropologists, who engage with behavioral scientists to better understand those shifts, societal norms, who can engage with non-engineering stakeholders. And it is important to have that engagement. It's important that our engineers have both the technical and the non-technical capabilities around leadership, because what you'll find is who is taking decisions on infrastructure investment. It's going to be people who finance infrastructure, it's going to be project managers, or it's going to be key influencers and decision makers. So in a way, we need to really rapidly change our curriculum so that we broaden the skill sets, not without losing the technical capability, but we really need to broaden the skill sets of future engineers so they can deal with non-technical experts, but they also are equipped to deal with AI and kind of the combination of challenges facing us, and be able to come up with new solutions in a disruptive world. So I'm going to pause here for now, Elizabeth.
Sorry, lost the mic. James, would you like to add on to that?
Yeah, absolutely. And I will definitely just build on Preeti's comments about doing things differently and thinking differently. I think that anytime, and I'll speak from an organizational perspective, anytime an organization comes up with a new strategic plan or a new strategy, you'll often hear something to the effect of what got us to where we are today won't necessarily get us to where we want to go. And the implication is that if we want to get to a future state that is different or better than our current state, then we have to do things differently. We can't keep doing the same things that got us to where we are today. And I think that certainly applies to what we're talking about in terms of a more sustainable future and more sustainable infrastructure, that we have to do things differently, because I think it's also, if we're being candid, the engineering industry and the way that we have done things in the past could have contributed or has contributed to the way things are today, which aren't necessarily sustainable. So we as an industry need to take a different approach. And I think you're seeing that. And so within GHD, my firm, and within the industry, I think you're seeing companies take a different approach to engineering and engineering design, where the focus, whereas previously the priority would have been around safety and function of an asset. And that certainly is still part of the focus, but it's not the only part of the focus. And you're seeing firms take a much broader view of what success looks like. And so going beyond just safe and functional, you're seeing firms look at the broader impacts of the infrastructure that we're designing. So looking not just at the first order impacts, but the second and third order impacts. So for example, looking at the impacts that an infrastructure asset may have on the, not just the surrounding community or the surrounding community broadly, but looking even more deeply at specific populations, like vulnerable populations in that surrounding community. And looking at the impacts on not just if you're looking at a water management asset, not just at the water source, but the broader ecosystem that is impacted and that depends on that water source. And so taking that broader view and looking at these broader environmental and social impacts, you can see that takes an expanded skill set. And I'll just make one last point also on doing things differently as an industry. I love, Sabina, that you brought up this concept of, and I hope I say it correctly, mutual. You said it means that collective effort, and we are absolutely doing that. And that's something different that we're doing in the engineering services industry, where we are coming together through a group that ICSI supports, the Engineering Leadership Group. And that is a group of GHD and many of our peers in the engineering consulting services sector, where we, although traditionally we may have been and we are competitors, we are collaborating together as peers in a pre-competitive approach, a pre-competitive fashion, but we are collaborating together to help bring a unified industry voice to advocate for policy for sustainable infrastructure. So those are some of the ways that we are doing things differently, and that we have to do things differently if we want to have a different and more sustainable future state.
Thanks, James. That's really exciting, and we'll get back to a lot of these, but first let's hear from Bilal.
Yes, I have a couple of slides to share, but before I do that, I'm at the University of Maryland. I have been an educator for 40-something years, and also I maintained affiliations with Imperial College in London, Tongji University in China, Hamad bin Khalifa University in Qatar, interactions with the University of Sao Paulo and the University in Germany. So I do have somewhat, this global maybe take in terms of where the education is going and what are the thoughts in there. And I can tell you, when it comes to an educational institution, we don't exist in isolation. We are embedded in most of the time, particularly if it is a state institution, within a system where we have to respond to the mandate that comes from the state, and there are constraints that we have to operate within. And then we are dealing with faculty. Most of the time, I could say that they are forward-looking, they are nimble, they are aware of the challenges, and always they are eager to bring all their experiences through professional activities to the classroom. I mean, the culture encourages that. So with that, let me just share with you a couple of slides. Although they focus at the University of Maryland, but they offer a typical case, if I may call it that way. Keep in mind that the University of Maryland is a state institution, and some private institutions, they might operate slightly differently. So I'm sharing the slides in here. So basically, what I'm showing in here, I put the question on the right-hand side. That was the primary question in here about the gap and the offerings related for just sustainable and a climate resilient future in terms of education. And then I put in the College of Engineering. I'm in the School of Engineering at the University of Maryland, and this is visual here. It's about a strategic plan, which is typical. I mean, you'll find always there is a vision, values, mission, and there are priorities. And this is really drawn from the university, from the campus-wide strategic plan. Now, the funding for the campus, typical state institution, comes through legislation. And the legislation is basically, they are elected officials. So they are responding to communities. And they create mandates in terms of admission and what things we should cover and how the degrees, to some extent, in terms of duration and so on, they could have influence on that. And they could control funding related to research and so on, but minimal level of funding, I would say. If you look at the Department of Civil Engineering, which is shown at the very bottom on the left, it shows that based on our strategic plan, and I'm not showing the details in here, that they identified 4 pillars, and the 4 pillars are in line with the strategic priorities. The first one is relevant to us. And if you look at the college one, it says reimagine how we teach to enhance learning. And you could, look at the other ones. But in our case, we wanted to tackle grand societal challenges. That's the first pillar. The pillar 2, 3, and 4, they are related, but the primary items in here, those societal challenges. Now, I'd like you also to note that an institution such as the University of Maryland, which is research campus considered and is highly ranked, basically, not only we have to worry about undergraduate education, but we have a sizable, maybe as big, graduate program, master's and doctorate level. And I'm not covering that in here. It tends to be driven by research, which is at Maryland. It comes to almost $1.2 billion a year in research expenditure. Also, we have continuing education. So the full workforce, not only we are worrying about the students that are coming in, but we have professional degrees for people who are already in the workforce to make sure that they are current related on issues that we are discussing in here, sustainability and resilience and economic efficiency and so on, and automation and robotics and things of this type. And also we have always we seek high school students to bring in some of the concepts early and engineering related, which will help us in recruiting students and so on. And we have an activities of this type that I'm not planning to cover. So I'm focusing only on undergraduate curriculum. The thing I'd like you to note that, I mean, again, we don't operate in isolation. So there is an accreditation process, which is in the United States, and there is something similar in many other countries. What you see in this table in here is the civil engineering body of knowledge outcomes. And the focus is civil engineering here, but other engineering programs, they have different tables. I'd like you to see just the headings. I mean, this is based on what the accreditation board requires. And we are accreditation typically for 6 years. We have to go for renewal every year. And you look at the headings in here. These are what's in the table. They are primary headings. You could see I selected sustainability, but then there are ethical responsibilities and so on. You could just scan through the headings. And sustainability, for each item, there is a sizable table with details of what to expect, what needs to be covered. And the details in the table, they are done by the institution. So we'll take the language from the accreditation and we interpret it based on our, as educators, the way we'd like to achieve that in terms of educational outcomes. And you could see how the rigor in all of this. And we have been through curriculum transformation recently, started about I'll say 3-4 years ago. And now it is being transitioned. We are transitioning into it at the present. And if you look, in this slide on the right-hand side, it shows the CE curriculum committee we came up with, that pillar 1, which I showed in the previous slide, and it's replicated in here. It shows what are the key items or the focus areas to go beyond the fundamentals. You know, math and natural science, social science, humanities. If some fundamentals will stay pretty much the same, they will be tweaked to some extent. But we try to take those items listed under Pillar 1 and cover them, not necessarily by separate course that covers the item, but it could be a theme that cuts through many of the courses. And this includes climate change, circular economy, reuse, sustainability, aging infrastructure, human-induced hazards, urbanization, the energy transition and energy security. And there is a big focus on computations, whether it's AI and programming languages and numerical methods. And on top of all of this, we have a constraint that we cannot have the degree going from 4 years to longer. So we have that constraint, which is shown at the bottom of the slide, that it is a four-year degree. And keep in mind, our stakeholders is the people of the state of Maryland, which means, you know, parents who pay tuition, they would like to get their kids to finish college and so on. And we have to stay within that limitation. So we have a limited number of credit hours. We get those students in under our mentorship and care for 4 years. That's the window that we have. Some of them, they will take longer, but ideally the program should be designed that it is feasible for someone to finish it easily with reasonable effort within 4 years. I'll stop here, but I thought this will give some background that we are working in bridging that gap, and we are the faculty are members of the community at large, and we take that role seriously and very responsibly to make sure that we prepare the workforce for the future. Thank you.
Thank you, Bilal. That was a great overview. And at least in the United States, most of the engineers that we graduate are from these large state schools. And so seeing all those constraints, whether it's recruiting students, trying to get all their courses in within 4 years, keeping their parents happy by not extending their degree, etc. One thing you didn't mention, but I think is likely implied, is those parents, many of them also want their children to get jobs after they graduate. And that's a great, I think, segue to James. I'd like to kind of pivot to you. So you've heard from Bilal and, of course, also Preeti and Savina about everything that from the engineering schools, what they can and can't do, but what are the competencies that you all are looking for when you're looking to hire these new engineers or, of course, provide continuing education for those already working there? What do you think are the skills that are necessary for your company, but also the leadership group of companies that are moving in this direction?
Yeah, thanks, Liz. I appreciate the opportunity to respond to that. And I'll maybe start with building on a point that a few folks have touched on, and in terms of a specific skill set, and that is that systems thinking, that systems thinking skill set. And I so like I said, several of us have touched on it. I touched on it earlier when I was talking about how when we are designing our projects, that we are now looking beyond just those first order impacts and looking at second and third order impacts. And that really does take this systems mindset. And just to give you maybe a concrete that when we for our projects, we have a tool that we call Sustained Design, and that's our sustainable project delivery tool. And it's essentially a set of questions that helps our designers and project managers identify and scope the specific environmental and social topics that are relevant or material to that project. And I'll just give you an example of some of the questions that we ask that hopefully will illustrate the need for systems thinking and of looking at ways differently than we have in the past. So we have a question on embodied carbon. So will the construction and or the operation, so looking beyond just our part of the life cycle of the asset and looking at the supply chain and then the future operation, will it require using significant quantities of virgin materials and or use of carbon intensive materials? So again, looking at the embodied carbon of the concrete, of the steel, of the aluminum, of the asphalt. So looking beyond just our part of the life cycle. Then I also mentioned questions around the environmental impact, and so we have questions around will the asset have significant noise, air, light, or vibration emissions? Again, not just during the construction, but during the operation, and will it impact sensitive receivers? And that's not just the environmental receivers, but the social, the human receivers. And speaking more about those human receivers, we ask questions around and will the asset impact or disadvantage any local stakeholders now or in the future? And so I guess I would touch on, I mentioned a few times about the looking beyond our part of the life cycle and looking at the future. That's another skill set, is that futures thinking, is looking at, oftentimes we'll refer to in sustainability the indigenous philosophy, I believe it's attributed to the Iroquois, of in every decision we need to consider the impact on 7 generations into the future. And so that futures thinking is another critical skill set. And maybe I'll stop there. I've got so much more I could say, but I'll stop there, Liz.
And so I just want to follow up on that and say, do you feel like the engineers that are coming, the young engineers coming into the firm, are equipped with that? And specifically, where do you think they could be leaning in further? What sorts of competencies? And this, it could be things like AI, or are there, do you sense that we're training young people in this direction, or is it still hard to find engineers, young engineers that really can take this on?
Yeah, there is definitely, I would say, if not the skill set, there is the passion and the desire. So we for sure see that passion and that desire and that interest in our new engineers. I'm not sure that they're coming in with the actual skills that they need to act on that passion. And I think part of that also is, and this is also incumbent on us as an industry to provide an environment where they feel safe to try to develop those skills. I think we need to make sure that our income understand that, hey, we are doing things differently than we have in the past, and we need to create that psychological safety, that safe space, to where they feel that they can think outside of the box, where they feel empowered to speak up as a young engineer. And so there's also very much a piece there, besides for us as an industry and for our leadership, because you did talk about leadership. There's a need for us to change the way that we manage, and to make sure that we are again creating that space and making sure that our young engineers feel that safety to think outside of the box. And I will say just one last piece about, because we've talked a lot about AI, and certainly there is a huge space for that in the industry and in innovation for the industry. It also, though, I think highlights the fact that we will still need those human skills. And I will just say that from my experience of more than of 20 years and working in engineering organizations, that those leaders that I have seen excel and rise to those leadership positions are those who have, yes, the technical engineering skills and those human connection and communication skills. And that's something that I just don't think that AI is going to be able to replace.
That's great. Preeti, I want to go back to you and follow up on that, and also Bilal's comments from UCL's perspective. Do you see these as competencies that you need to further evolve within your curricula? And if so, are you moving in that direction, or would you like to? I'm also curious if the situation as described in the US by Bilal at Maryland, if that resonates with the system that you're in and other universities that you work with.
Sure. And I think, James, you've set us up nicely with a challenge of how can we make sure that graduates coming out of our universities can address the needs for organizations like yourself, especially around kind of future scenario planning, around different mindset for AI and sustainability. And I was just reflecting on a project that I'm working on in East Africa called Listen, Learn and Leap, which is very much a project where we are working on nature-based solutions for climate resilience in informal settlements. And what we are finding there is we are reinventing the wheel around how to co-develop those solutions with local communities. And we are rewriting the construction playbook on how to do that in a just and equitable manner. And to the point, we're redefining what nature-based solution means for that context, and also bringing livelihood, because there seems to be a big drive towards people positive and nature positive solutions. And that's kind of highly contested and debated in sub-Saharan Africa. But what that means is we need engineers, our graduating engineers, to shift from that traditional top-down approach to be able to set out different scenarios with those local communities to co-develop the solutions so that those stakeholders feel they have ownership to operate and maintain that asset further down the line. So it does need an absolutely new way of thinking, and it needs that combination of sustainability, digital capability, technical capability, and leadership. And it's interesting because at UCL in my department, we recently introduced a new undergraduate program which is an integrated 4-year MEng. So it's bachelor's, 3 years plus a year of master's, called Construction Engineering, Innovation and Leadership. And this is one of the few undergraduate programs where we introduce leadership in year 1. So we're teaching 18-year-olds the technical competencies around engineering, but also leadership and sustainability, and all those strands run together. And in terms of accreditation, this has posed an interesting challenge for us, because with accreditation in UK, the stipulation is for engineering accreditation, you need X number of technical modules. But by introducing strands of leadership and sustainability in year 1, it means that actually we are also introducing the soft skills early on, which reduces the number of technical modules. So we are kind of leading those conversations with professional bodies on how to get those programs accredited. So in a way, we are kind of almost rewriting the rule book on accreditation as we speak, and those conversations are very much active. But it requires a lot of kind of conviction and courage to do that, because for a lot of students and parents, that accreditation is important. So to move away from that and take that risk,
exciting space for us around kind of accreditation. And I also wanted to touch on AI, because I know AI is very much on everyone's minds, because AI is really changing the way we work. And in conversations with big construction firms, they're already thinking about how do they deploy the human resource differently 10 years down the line. What can drones and robots do, and what will human beings do? And for me, if you think about climate change and resilience, the AI could be a force for good, because we can deploy them in post-flooding scenarios, in scenarios where it's not safe for human beings to venture in and to fix infrastructure. So, I mean, AI does have potential for the work we do, but I think there's a bigger question around how can we train our engineers to be ethically responsible? How can they question the truth, question what is being churned out of AI, to make sure that the information is valid, it's accurate. And I know there's a bit of worry around AI, that AI is probably going to lead to loss of jobs. I don't think that's the case. I think it's just making sure that engineers are able to use AI. So for me, it's not a matter of training every engineer to be an expert on language models or on clustering algorithms or machine learning models. It's for them to understand how they work and the interpretation of that. So I think for me, there's still a place for human skills in our curriculum, but it's kind of understanding the ethics of that and collaboration, partnership, and understanding that whole piece around sustainability systems thinking. And I can say more, but I'm going to pause here for now.
Great, thank you. Bilal, I think this is sort of a full circle from where you started the presentation, which is a really nice way to think deeply about curriculum development, etc. In this whole process with the university, I'd like you to comment on whether AI became a talking point, how to incorporate that into your curriculum with these other pillars, but also just stepping back, the people who were driving the university's strategic planning are not necessarily the young engineers with their interests in sustainability. So how do you mesh the movement of sort of younger engineers and technological, but also values-driven with the sort of institutional, sometimes older and more established groups that are actually setting the vision and the mission and the direction? I'm curious how that all played out in your situation.
Yeah, thank you. I think building on what was stated earlier, we do have in our curriculum systems thinking. We have whether it's the courses, a graduate level program, and a degree devoted to systems engineering, as well as leadership skills, and seeding some of the initial thinking at the first year freshman level. For example, we have an engineering design course that is at the freshman level, where they will start to see that when you deal with design, it's not limited to one discipline. You have to bring in many other fields, right? Including sustainability. We have it at a lower level, with the challenge that was described earlier, that we need still to bring in the fundamentals. I mean, I can tell you some interesting statistics. Half of our graduates from the civil engineering program, they will end up working in fields which are not civil engineering. They will be in naval architecture, in finance, in all type of things. So we need to prepare the students to be comfortable, in my opinion, to venture across fields. And we do that. And the soft skills, extremely important. We always try to get them to work in teams. So there is a person leading the team or leading different aspects of the project and working together and coming to basically reach consensus of what's the next step, and consult with professors almost in advisory capacity whenever they need technical expertise in an area that they were not exposed fully to it. So all of this is coming together. We are in the new curriculum, we have basically courses that are project oriented. So and they will, so basically they have to go and reach out and bring different disciplines together to solve a problem. And the problem is defined by practitioners. So we'll engage, the practicing engineers, including state engineers and so on, and they could present them with a bridge related problem or a building or whatever it is, and they have to deal with it across several disciplines. We have a project at the very end, which is required, where they have to a design project where they have to pull all the pieces together. Economics and economic efficiency is emphasized, and it's a high focus. But going back to your question about AI, I mean, AI, computations in general, I'll say that we do have coverage from numerical methods to programming, whether it's Python or other tools. And we'd like to also educate them so that they are not tied to a particular programming language. So, I mean, they will have exposure to several. So after a few of them, they'll start to realize that they can easily pick up any other language and deal with it and so on. And using AI for programming, which is what some students do now and so on, it will give you the code. AI, we have the implementation of it is very active on campus, and we have a whole office devoted to it. There is an institute that was established, which I'm part of it, is the Maryland AI Institute, and it's focusing on both research, and the topics are cross fields. I mean, this is not engineering, social science, economics, and so on. Quite interesting grant even program from the institute, seed funding, to get people focusing their attention. You asked another question on strategic planning and engaging the young and the experienced people. In our faculty, we have about 30 professors, and the age distribution is really cover the whole spectrum. So you have really young people who are comfortable with coming just recent graduates, doctoral degree graduates, and so on, quite aware of all the trends and technologies and so on. And the experienced one. I mean, those quite few of them. They are very nimble and they jump in few areas comfortably. So I think it has been including all the topics. I don't think there was any challenge in that regard. The challenge, I'll say the biggest challenge is, what can you fit in 120 credit hours in 4 years? That is the biggest challenge always, just because there is so much. And I think the way I look at it is we have to train them on fundamentals. I can give you an example. If somebody sees a differential equation, a second order or fourth order differential equation, they should be able to easily see that it could be engineering mechanics, could be fluid mechanics, aerodynamics, it doesn't matter. All of it comes down to that form, which I need to solve it, and the solutions is available to us. So they have to be able to be comfortable across fields. And fields come together for the big challenges, often engage many disciplines and often outside civil engineering. And I think the students are almost there. I teach an undergraduate course on probability and statistics for civil engineers. And I can tell you, I always, in my examples, the minute I bring a practical example based on whether it's an advisory role I took or consulting or a research project, you'll see the eyes of the students open up and they will become very keenly interested. How did you deal with the decision of recall of some bad product in the market, which is economic legal decision to some extent? Or how can you deal with protecting a city such as in New Orleans with the hurricane protection system when we did the work many years ago, and so on. And there are many of those examples. So so we'll try to bring, and that's I think typical for most of the faculty. I sat in reviewing teaching methods and of other faculty and so on, and I attended many classes by other professors to give some form of comments and input to their teaching, and they tend to do that. So I think it's a setup. I mean, I won't describe it as perfect, but I could describe it as being dynamic, right? People are responsive, nimble to the future needs, and they try to meet it. But you know, one item which is important in my opinion, I know we have educators and we have engineers, practitioners, James, and the needs of the company. But the key item is increasing awareness by owners of assets, because the owners, they really set the requirements. So I think, you know, sometimes they might end up dealing with an engineering firm. Most of the time they do, out of the engineering firm ethical responsibility, they will highlight what the customer should ask for or what should have in their requirements, but it might not be the case, right? In my opinion, customers should be asking for sustainability, long life. Key item is long life. I mean, the other, I don't know if you saw, there's a movie that just came out and it talks about how the use of stone in building over the years, right? And how now we are comfortable to ask for a structure or a system, a bridge, a building to be designed for 100 years. In old days, I mean, that's too short, right? Now we are dealing with life extension, and then it has to be redone and so on. And it doesn't make sense almost. Well, why would you 25 years, 50 years, spend millions of dollars for such a short time? I think, you know, that's an item which is really underpinning for many other things. Why don't we design for much, much longer time?
Thank you, Bilal. We have a couple of questions now, and anybody else will try to get to as many. Ramiro, great to see you joining the group. Would you like to come online and ask your question? You are muted.
Sorry. Hey, Liz, it's been a while. I'm Ramiro Jordan, University of New Mexico. This is where we started. We organized the first global peace engineering conference in 2018. And since then, we have a consortium. We meet every Friday, and we've been building the knowledge on peace engineering for years. Peace is sustainability. Engineering is problem solving. People get scared when they see the word engineering. So we build this knowledge, and it's peace engineering is the convergence of all disciplines to solve grand challenges. We always start with one planet, one environment, one chance. And how do we educate the global citizen? So we created a minor at UNM, and we asked the question to the students, what is your footprint on the planet? How much trash you generate? How much water you waste? And so on. And the most important thing is the scientific method. Verifiable, trusted data. This information is the biggest threat that we have. So this is something that we're pushing. So the reason I ask about quantum is my school has been working in quantum informatics for 27 years. A lot of the people that graduated have built those quantum computers. I was just in Brazil, pre-COP meeting, when we talked about sustainability, innovation, and peace engineering. Quantum came up because this, I don't know if you're aware, the central banks are investing in quantum because the first industries that's going to take a hit is going to be the financial industry, because you can break codes. We need to start preparing the next generation. It's more this systems thinking, it's about convergence, and it's about the scientific method. We have to combat disinformation. Open science is key. We have to make information symmetric. Asymmetry creates conflicts. Once you have a conflict, if you end up in war, it's too late. So this is what I'm trying to, we're pushing this in peace engineering. Here's something that for you to interested to just look at. The intergenerational transfer of money. Never before has so much money accumulated in the financial industry. $84 trillion will be transferred. What do we do with those resources? And this is exactly, I really like what you're organizing, and I want to try to join you for the rest of the sessions, because I think we need to make a difference. And it has to be all together. So what do we do with that? So we're really pushing for peace technology, right? And it has to be local. Thank you. That's all I wanted to say. Let's throw out the questions there to really challenge everybody. That's all. Thank you.
All right. Thanks, Ramiro. And I don't know if anybody wants to respond. We're running short on time, and so there are a couple other questions. Should engineering educators also be educated in new topics and approaches? And then also from Vincent in Uganda, educators need an accelerated, training or empowerment program in AI adoption. Students are already ahead of the educators. I think these are related. Does anybody want to respond quickly? Yeah. All three of you, why don't you take those, and then Sabina, we're going to let you have a few more comments before we move to wrap up.
Sure.
James?
So, James.
Oh, sure.
Yeah, great. And maybe I'll try to address all of those questions at once in a very succinct answer. And I don't want to minimize the importance of or even mask industries sometimes challenges in staying up to date with the latest technologies. So whether you're talking about quantum information systems or AI, I will say though that because the engineering sector has historically is a technical sector, a technical industry, I have less concern about the industry understanding the importance of and staying up to date on different technical skills and technical advances. Where my biggest concern is on those human skills. And so I just want to point out, so I didn't say soft skills. I'm not a big fan of the soft skills versus hard skills, because it feels like it makes one feel more legitimate than the other. But I think you certainly have technical skills and human skills. And those human skills, that's where my biggest concern is around the industry and how and in higher education, how we're preparing students for industry is in those human skills. And in particular, you know, we've talked about systems thinking and futures thinking. And well, I think a skill that is critical to those skills is, and this is this human skill, and this might be surprising to some to hear in an engineering context, but it's empathy. It's empathy, because empathy is systems thinking, and futures thinking is understanding where we sit in this broader system currently and in the future, and not just how we sit in that system and how we impact, but how we relate and connect to other parts of the system. And that's where that empathy comes into place. And there are several different frameworks, whether you're talking about the EU's rounder sense of purpose, or the inner development goals, and several other frameworks that actually highlight empathy as an important sustainability competency.
Preeti?
Sure. I'm head of department for a multi-generational department where we have staff members, colleagues from the age of 20s to 70s. So when we discuss new ideas, topics, especially, for example, AI, the conversations are always very interesting. And around that, there are a couple of key points which emerge. And one is around how do we use AI to deliver teaching, to do our assessment differently, because our students are using AI. There's an appetite to use AI for coursework. So then how do we manage that through our assessment processes? What are the new ways of engaging with our student body? Because they are, quite frankly, as you highlighted earlier, ahead of the game compared to us when it comes to use of AI tools. But where we have an edge is the kind of ethical use of those tools, making sure there's kind of understanding on what is accurate knowledge, making sure there's the whole process of validation, sense check, so that AI is not just used blindly as a tool. And then the second part, which is very interesting, is the research on AI and kind of identifying emerging themes and topics around where AI can be best deployed in the kind of construction and project lifecycle. And whether it's going to be deployed on improving our knowledge on energy saving of buildings, or whether it's going to be deployed on improved knowledge and use of sensors and digital twins. So I think there are a couple of interesting strands emerging around the use of AI in academia and engineering education, and all of that needs to be shifted and transferred to education quite rapidly, making sure that our students have those tools to make informed choices and decisions. I can talk more about it, but I'm conscious of time, so I'm going to pause here.
Savina, I want to make sure you get a chance to weigh in again.
Sure. I mean, I know, Bilal, you had something that you wanted to say as well. Maybe before I do, we got a few more minutes, Liz, to
I mean,
go on.
I'll
Yeah.
take maybe 1 minute. There was a question about ethics, I think just was added a minute ago. And I have some perspective on this. I mean, we all know that when it comes to economics, which is at the very end, could filter basically projects and make a decision which way to go in terms of features and so on about economic efficiency. I mean, we know in economic modeling is often what we use is anthropocentric valuation system in terms of the most prevailing method is what's called willingness to pay. And sometimes we look at GDP and impacts if we're looking more at the well-being of a society and so on. And those economic models in terms of economic output or willingness to pay market value for things, whether it's human life and safety and so on. And that's very well established. It's all, again, it's a human-centric ethics system, right? And that certainly is an area which is of great concern, at least for me. And there is a need for maybe revisiting this and maybe broadening the horizon of students. I agree with the comment that it should be drawing what's called their non-negotiables or things of this type. It's an item which is worth seeding in the thinking of students and future leaders. And another concern is our relationship with nature. which is more on philosophy, founded in philosophy, really. If you look at the way we look at nature in terms of land ownership, is about land rights, what you could extract from it and what you could use it for, and so on. And that is unique. It's really a Western thing, which is in the US as here as well. Strong land rights, and it's locally managed and so on. While if you compare it to other maybe more Eastern cultures, there is a major a tie which is totally different, and this feeds into the environment, into sustainability, and so on. So I think maybe bringing those perspectives in can be quite helpful. Thank you.
I'll just come in, I guess, after listening to this very rich conversation, and thank you for joining, James, Preeti, and Bilal. This is after sitting in all the sessions we've done to date. I think we kind of are learning and kind of hearing quite loud messages on what would be required. I think it sounds like we know what would be required in terms of what topics. There are examples out there of universities that are already putting this into practice, learning by doing, right? The point of bringing together this group on transforming engineering education is creating that sort of peers sort of community of practice, and the value there is because we need to go a lot faster in transforming engineering education on one hand. So we don't want to reinvent the wheel necessarily. Some universities don't have a lot of resources, and they could actually do with learning from others already doing this. And so that's the point of bringing all of us together. And acknowledging that it's not just educators, and it's also the industry that James today represents. It's kind of bridging that sort of industry and university sort of gap that currently exists and is constantly evolving. Definitely industry evolves faster than university. Like hopefully the gap is not widening, and actually we need to close it by collaborating more. And also others, right? The professional associations. So I know professional associations are for professionals, but many of these have student chapters. I think that's a good way to close that gap. I see people who joined us today. Jonathan was a speaker in our previous session. He's from Engineers Without Borders. Those are organizations that are working towards this. And so thank you, Jonathan, for joining us today and for doing the work that you do. So that's the collaboration on us. And then there is raising our voice in the fora such as COP, getting the policymakers' attention, because we need resources that to reform engineering education. It's not just done, like on a whim. We need a plan to develop capacity in different countries so that we've got engineers of the right quality, not just quantity, but right quality to put in practice what Ramiro was talking about, the one planet, one chance. We don't really have a lot of time or chances. We just really need to come together a lot more. And so thank you for this. You've given me tons of ideas and tons of things to bring back to COP and try and, amplify this, because we need the attention of the policymakers. And so that's kind of what I'm going to try and do with these messages of we need to develop our workforce. And so transforming engineering education plays an absolutely essential role. And we are forming a coalition of different actors and organizations that are working on this, which is great. So that's kind of all for me, and kind of like comments to contribute to the panel. But we do have one more speaker, right, Liz? Back to you, but I think you're handing it back to someone else. Rowan, in fact.
Yes. Thank you, Rowan. If you can get pinned up on the screen, I'm going to let you have the final words. Rowan Palmer is with the UN Environment Program and has also been working with ICSI and Duke on our ISLE initiative. Rowan?
Thanks. Excuse me. Thanks very much, Liz. And thanks to everybody all the panelists and all the great questions. Have been a really, really interesting discussion. I'm going to try and summarize things and then end with a couple of takeaway thoughts. But yeah, it's been a really, really rich conversation. We started hearing about the sort of changes in the types of challenges we need to address, and these new, more dynamic challenges need new dynamic solutions. I think it was James who made the point, we can't, what's gotten us to where we are now can't get us to where we want to be in the future. And I think we've all heard the quote, something along the lines of, the definition of insanity is continuing to do the same thing over and over again and expecting a different result. So clearly we need to rethink the types of solutions that we're putting in place, and this requires new types of skills. James kind of talked about sort of some of these more human-centered skills, and for me that speaks a lot to sort of changing mindsets as a sort of precursor or a more fundamental shift to changing the way we do things. But he talked about sort of futures thinking, systems thinking, and these kinds of things. But of course, you then still do have like the more technical skills, as he called them, that this kind of thinking necessitates, and to be able to put it into practice. And so we saw, we heard from Bilal that he raised the good point that it's great to be able to talk about these things, but of course in practice there are a lot of constraints faced by education programs, particularly in universities. There's still a basic level of core skills and fundamentals that needs to be covered, and then we're trying to add in more things. So I think that's a significant challenge. Pretty raised the point, it's not just about the curricula, but also about the accreditation programs and sort of the mandates and what needs to be covered by the curricula. So there's sort of numerous constraints and challenges, but we also heard about interesting ways that some of the programs are tackling this. I think, in the discussion afterwards, we heard a lot about the need not just to educate the engineers, but also the clients. And I think that's really important, because essentially, as we've said, engineers are problem solvers. And I think appealing to sort of that nature of people who are in these programs can be effective, and sort of a focus on, helping people want to become and understand how to be better problem solvers so that they can offer and provide more value to clients, and sort of be, providing smarter solutions, basically, which I think sort of appeals to the typical engineer for sure. But then, of course, you need education on the client side as well, on the kind of things that they're asking for, and the kind of things they're valuing. And somebody else, I think in the chat, maybe made the point also, the educators as well. Priti, I think you just said you have a sort of a multi-generational program that you manage, or faculty you manage. So I'm sure there's a lot of different levels of openness to new ideas and new ways of doing things. I think we perhaps inevitably ended up discussing AI as well, and I think I like the point James made about the sort of the technical side of that he's not worried about. But it's more sort of what applications it's used for. I think, how can we use this for sustainability, or for peace engineering, as Ramiro talked about. So how these new technologies are deployed, I think, is the important question. And I think something sort of as my takeaway thought, something that the Bilal said on this question of sort of ethics and what we value is really important. And he talked about our relationship with nature, and even at UNEP, where we are advocating for more nature-based solutions and integration of nature into engineering solutions and this type of thing. I mean, we're still taking it from an anthropocentric point of view and thinking about the value of the services, sort of the economic value of the services it can provide. And I think there is that sort of bigger question of what we value. And there was an interesting discussion in the chat too between James and Christy about sort of this idea of trade-offs. And I think if we do change what we're valuing and the kind of outcomes we're going for, it may not eliminate any trade-offs, but it might make some of them easier to manage. And I think that's an important sort of underlying shift. And then maybe some of the details can fall into place around that. But yeah, I'll leave it there. And thanks everyone for a great discussion. Yes, my last job of the session. So we have another IELTS session coming up on the same topic on November 25th. You can scan the QR code. I think there's a link in the chat that Gemma just put it well. So we would be very happy to have anyone that's here join us for that as well. So please do scan the code or click the link, and we hope to see you next time. Back to you, Liz.
Okay, just thanks so much, and hope to see folks for the rest of the sessions coming up. And thank you to ICSI.
Sure.
And of course, our wonderful panelists.
Thanks, y'all.
Thanks,
everyone.
Thank you.
Thank you.
Thank you.
Bye.